This is the fourth video in this series devoted to information, theory, and math card magic. Today we'll look at examples that make use of surprisal values. Now, our first example involves a video I have already posted to my channel. It's on the top left-hand side of the screen. It's called Read 3 Minds at Once. And I strongly recommend that you watch that video before you proceed with the current video here. It will make so much more sense if you watch that first. Now, if you choose not to watch that earlier video first, I can quickly give you a bird's eye view of what it looks like to the spectator, okay? So what you do is you have 3 piles of 3 cards each, randomly dealt to the table, and the spectator can do the mixing and then the dealing. Then for each of the 3 piles, what you do is you show the spectator the identity of the cards within each of the 3 piles. So for example, the spectator is now free to choose and make note of any one of these cards here for pile 1. Once that's done, you repeat those same actions for pile 2. You go ahead and reveal the identities of the cards in pile 2. The spectator is free to choose any one of these and note that down as their selection from pile 2. And finally, from pile 3, they can choose any one of these cards here. So once they've written down their selection for safekeeping, these cards are then stacked on top of either one of the other piles, and then these are randomly stacked as well. Now from there, this packet is thoroughly mixed, and that is demonstrated in the video mentioned on the top left-hand side of the screen. And then after the mixing, the cards are again set out into 3 piles of 3 cards each, and the spectator just needs to identify. I'll have the cards face down this time if that's okay. But pretend these are face up. The spectator is looking at these cards, the faces of the cards, and we ask just one question. Which pile contains your first selection? And knowing which pile contains their selection, you, as the performer, are able to immediately state the identity of their first selected card. Then you ask them which pile contains your second selection. The moment they speak the words, you're able to identify the spectator's second selection. And then finally, you ask them which of the 3 piles contains their third selection. And with that information, you can immediately state the identity of their third card. Okay? Now, anyone I've shown this to has been visibly surprised that I am able to correctly state the identity of each of the 3 cards that they freely chose. So once again, I encourage you to watch that video, Read 3 Minds at Once. So what we're going to do now to tie it to information theory, let me just move these up here. We're going to first calculate the probability that I could, by chance alone, guess the correct card. And the probability of doing that by chance alone would be the following. For the first pile of 3 cards, for me to randomly guess the spectator's first chosen card, there would be a 1 out of 3 chance of me doing that. So 1/3. For the second pile, it's the same thing. There's a 1 out of 3 chance that I would just randomly also choose the card that they chose out of those 3 cards. And the same thing holds for the final pile, pile 3. I would have a 1 out of 3 chance of randomly guessing correctly the third card they chose. Now, since these are, quote, independent events here, we multiply the corresponding probabilities. So the probability of me succeeding in correctly guessing all 3 of the spectator's chosen cards is 1 out of 27, okay? Now, earlier in this series, the work of Claude Shannon, who is the father of information theory, he gave us a wonderfully powerful perspective in interpreting these probabilities in the context of ordinary coin tosses. Okay, so if you remember, the surprisal value for a single random event that has probability p of occurring is equal to log base 2 of 1 over the probability, which is equal to, here, log base 2 of 1 divided by 1 divided by 27, which equals log base 2 of 27. And that is approximately equal to 4.75 bits. Well, I think that's close enough to 5 bits. We'll go ahead and round it up to 5 bits. And so the interpretation that we gave earlier in the series, and it does in fact apply here, is the following. The surprisal, or degree of surprise, associated with me correctly guessing the identity of all 3 freely chosen spectator cards, is the same degree of surprise one would experience in tossing 5 fair coins high up into the air, and while the coins are in the air, you call heads on all of them. And then the coins land and bounce around on the table and eventually settle down. And guess what? All 5 coins are face up. So that is the degree of surprise associated with this first performance. So that's read 3 minds at once. Well, within the second video on the left, bottom half of the screen here, I go into depth analyzing the original performance by Miss Mag 822, in which he works with 5 piles of 5 cards each. And then within this video here, I also first look at 4 piles of 4 cards each. Okay, so let's look at each of those in turn. So what we're doing here is we're essentially doing the same thing that we just did, but now we're going to have 4 piles of 4 cards each. So there we go. There's 4 there, 4 here, and 4 here. And then these are random. These can be randomly dealt to the table by the spectator. That's the important thing. There's no setup to this at all. There's no trickery with the cards in any way. The spectator is freely choosing these cards, okay? So as the performer, I have no idea what these cards are, okay? So what does it look like again? Well, if you watch the video on the bottom left-hand side of the screen, what it looks like is each of these is turned face up, and the spectator is free to choose any one of these as their card from pile 1. And they would jot that down on their piece of paper, okay? They do the same thing for pile 2. They just randomly choose whichever card they would like or whichever speaks to them. And they would jot down the identity of that card as their chosen card from pile 2. And they repeat that for pile 3 and pile 4, okay? Now, after that's done, these packets are randomly stacked by the spectator, truly randomly stacked. And then we go through extensive mixing and, quote, randomization of the packet, okay? And then after all of that is done, the cards are again put out into sets of 4 cards each. And with those cards now face up, you ask the spectator, well, which pile contains your first selection? The moment they tell you which of the 4 piles contains their first selection, you know with certainty what that card must be. And then you ask them which pile contains your second selection. And the moment they tell you which pile contains their card, you know what their second selection is, and so forth for the third and fourth piles. Okay, so the actual procedure itself is the same as that used for 3 piles of 3 cards each. So let's take a look at that. So now imagine we have 4 piles of 4 cards each. For me to randomly choose or guess the spectator's first card in the first pile, I have a 1 out of 4 chance of doing that at random. The same thing holds for the second pile and their second selection, their third selection, and their fourth selection. So the probability that I would correctly guess all 4 spectator-chosen cards is 1 divided by 256. Well, in terms of surprisal value, this becomes log base 2 of 256, which is exactly equal to 8 bits of surprisal. Okay, so how do we interpret that? We interpret it in terms of ordinary coin tosses. So imagine having 8 fair coins, tossing them high up into the air, while in the air you say all of the coins are going to land heads up. And they do. So that gives you a sense of the degree of surprise you would experience or a spectator would experience in watching the performance read 4 minds at once. Okay? So essentially we went from 5 bits of surprisal for read 3 minds at once up to 8 bits of surprisal. Okay? Now the original read 5 minds at once, of course, will have a larger surprisal value still. So once again, this involves 5 piles of 5 cards each. The spectator is free to randomly choose these. I'm just setting out cards that you can kind of imagine what this would look like. Okay, so 5 piles of 5 cards each, randomly dealt to the table, and then the spectator goes through. So let's go ahead and we'll just put them in some order. In fact, maybe we'll have to go like way up here and then down here. I'm just trying to fit them within camera view here so you can see them. Okay, there. And then maybe this one down here, I guess. Okay, so what would be done once again is this pile, the identities of the cards would be shown, and the spectator on a piece of paper, preferably. Now, what is nice is if you happen to have 5 spectators or more, you can assign 1 pile to 1 spectator. And so that way they only have 1 card to remember. Now, if you only have 1 spectator, they can just, on a piece of paper, write pile 1, and then maybe they randomly choose the Queen of Hearts. They do the same thing for pile 2, 3, 4, and 5. These piles of 5 cards each are then randomly stacked by the spectator. They can decide how this is done. And then, as done in the original performance, and my explanation and exploration of this principle, this packet now is just randomly mixed. It's mixed thoroughly, at least in the minds of the spectator. Okay, and that's the key. It is convincingly mixed, but because of the principles taught on the Hidden Structures channel, it ends up that we still know enough about this packet to be able to finish in the way we hope to. Okay, so then these are put out into, so it's been mix, and then 5 piles of 5 cards each again. Okay, and then we do the same thing where each pile is turned face up so you can see them all. And then you ask the spectator which pile contains your first selection. And the moment they tell you which of the 5 piles contains their first card, you know without a shadow of a doubt what card they chose for that first pile. You can immediately name it. And that's true for the second, third, fourth, and fifth card that they selected. Okay? Well, the probability here now, if we have 5 piles of 5 cards each, the chance that I, as the performer, would correctly guess the spectator's freely chosen card is 1 out of 5 for each of the 5 piles. Well, this comes out to be a probability of 1 divided by 3,125. The Surprisal value now is 11.61 bits, which I guess we could round to 12. 12 bits of Surprisal. Now, fairly recently, I performed this exact performance here, this exact routine, to one of my math classes, and I wish all of you were there to see and hear their reactions when I went through and nailed every single selection from each of those 5 piles. In fact, I remember hearing at least 2 gasps, like, what the heck? And of course it was followed with, you've got to show us how that was done. Okay, so quickly, of course with a single deck of cards, you can do 6 piles of 6 cards each. That would only be a total of 36 cards. There's 52 cards in a standard deck. If you were to do that, the Surprisal value now jumps up to 15.51. So that's like taking 15 fair coins, tossing them into the air, calling heads on all 15 coins, and watching them all land heads up individually. Absolutely amazing. And that's the degree of surprise the spectator or spectators would experience in watching this performance here. And of course, we can go up one more and still stay within a standard deck of cards. We can go up to reading 7 minds at once. So 7 piles of 7 cards each, in which the spectator is freely choosing a card from each pile. The piles are randomly stacked and mixed thoroughly. The cards are put out a second time, and now the spectators just asked, where is your first selection? Which pile of 7 cards contains your first selection? The second they tell you, you know with absolute certainty what their first selection must have been. And then you can do that for pile 2, 3, 4, 5, 6, and 7. You can nail each and every one of these. And typically what happens is when you successfully guess their first selection, there's a fairly mild reaction like, oh, wow. Could be by chance. You had a 1 out of 7 chance of doing that. But as you continue to nail each one of these, their surprise, and in fact the Surprisal value just skyrockets. And I want to point out something here. The Surprisal for 7 piles and 7 cards each, it's almost 20 bits. Well, the Surprisal associated with being struck by lightning, and a person can look this up. You can look up the probability that an individual would be struck by lightning. It has a corresponding Surprisal value of 18 bits. So this right here would be more surprising than being struck by lightning in the sense of the probability that that would occur. Okay, so very, very unlikely. Okay. And then I have a summary here if you want to see a summary page of the comparison of the Surprisal values for each of these. So 3 piles of 3, 4 of 4, all the way up to 7 piles of 7. And we can see this progression, of course, of Surprisal values. I'd like to give you another interpretation for just one of these. There's so many interpretations for the Surprisal value. One is in terms of coin tosses. That would be fine. An equivalent way to look at any of these, actually, is why don't we focus on 6 piles of 6, and we'll even round down the Surprisal value. We'll say it's just 15 bits. So the surprise associated with watching the successful completion of that performance is the same level of surprise someone would experience in taking a 15-question true-false exam for which they have not studied and they're forced to just randomly guess the answer for each and every one of those 15 questions. So the surprisal associated with this particular performance is the same, or a little bit more, than the surprisal one would experience in getting all 15 of these true-false questions correct. So you ace the exam. You get 100% on the exam, and you were randomly choosing T or F. You had no idea, okay? So that gives you another interpretation of the degree of surprise one would experience in witnessing this particular event. And that's true for the others as well. You know, if we want to round it to 11, it's like acing an 11 question true-false exam for which you have no idea what the answers are. And then this one's almost a 20. 20 questions for which you have no idea what the answer is. And you just randomly write down TF, FTF, so forth, and you nail it. You get 100% on that crazy exam. Well, that's the same level of surprise an individual would experience in witnessing the successful performance of this routine here. Okay, well, thank you for watching, and we will be looking further into applications of surprisal theory in mathematical card magic. And we may even explain and give you further tools from combinatorics that will enable you to calculate these probabilities and surprisal values for yourself. So thank you for watching.